Hi, I'm Barnas Monteith, the organizational PI at the Center for Science Engagement for Project LogicDS. The LogicDS project is a research and development initiative funded by the National Science Foundation under the DRK-12 program. Its primary goal is to make data science education more accessible to high school students, particularly those in rural and underserved communities who often face educational barriers related to advanced STEM courses and qualified teachers. The project addresses this by developing a virtual, self-paced curriculum. A core aspect of LogicDS is its novel pedagogical approach based on unified logic, using mathematical logic to integrate the foundations of computing, mathematics, and statistics. This approach aims to create a universal language that unifies these subjects, potentially making data science concepts more accessible and reducing cognitive load. The project is a collaborative effort involving Texas Tech University, the University of Florida, WestEd, Concord Consortium, and the Center for Science Engagement. Initial research has included a pilot study called the Week of Data Science at Florida Virtual Schools, which involved 110 participants and utilized 6 of the project lessons. These lessons cover different aspects of data science education using engaging themes like music, influencers, and social media. Key initial results from this pilot included enhanced familiarity with data science. Before the lessons, only 3% of 93 surveyed students reported knowing a lot about data science. Afterwards, this figure rose significantly to 43% among the 65 students who were surveyed at that point. High student satisfaction. 75% of 64 surveyed students agreed or strongly agreed that they enjoyed the learning experience. Students noted enjoying the use of popular figures and influencers, as well as the interactivity and immediate feedback, which felt like having a real teacher there. One line of research utilizing data from this pilot is the entropy analysis of student engagement. This study used student activity log data from the LARA, or Activity Player platform, where the online course prototype was hosted. This learner log data includes various student actions like focusing in and out, scrolling, submitting answers, changing pages, etc. The analysis involved a substantial amount of data, with over 200,000 rows of data in the learner log. Entropy was measured using Shannon's formula, and this was used to quantify the uncertainty or the information within a student's activity sequence. To compare how entropy varied, the coefficient of variation, or COV, was utilized. Key findings from this initial entropy analysis include a significant difference in learning performance that was observed between students with high COV and low COV. Students with a greater variability in their entropy exhibited higher performance, suggesting that flexibility and adaptability in learning behaviors may positively influence their academic outcomes. Importantly, the analysis found a lack of significant difference in entropy-based learning behaviors across students with different backgrounds. This suggests that the LogicDS curriculum provides an equitable learning experience for a wide cross-section of different students. And this supports the idea that well-designed digital learning environments can help mitigate traditional educational disparities. This type of analysis can also be used to understand different types of engagement, identify potential difficulties, correlate with outcomes, inform subsequent qualitative research like clinical interviews, and potentially modulate course materials in real time in future systems. Following the discussion of engagement, another key area of investigation within the LogicDS project focuses on how students learn functions within this integrated framework. The lessons covered various aspects of functions, including different types of values, functions on these values, and general functions, integrating programming using Python on Jupyter Notebook seamlessly. The research specifically investigated student understanding of 4 function competencies: identifying functions, IFUN, reading functions, RFUN, writing functions, WFUN, and designing functions, DFUN. Identifying involves naming inputs and outputs. Reading is finding the value of an expression using functions. Writing is creating expressions to answer questions, and designing is specifying a function for a concept. Initial analysis of these answers showed that students can understand the basics of general functions. For straightforward questions, high percentages of students gave fully correct answers. For example, 79% for IFUN question 1, 88% for RFUN question 1, and 82% for WFUN question 1. However, some students encountered more difficulties in involved applications of functions. Specific difficulties included problems identifying inputs or outputs for basic functions, using the proper form for writing functions, and issues with specifying inputs or output descriptions when designing functions. The findings suggest that while the systematic treatment of general functions is within reach of high school students using this approach, continued learning and practice are needed to master functions in more complex applications. The full pilot LogicDS curriculum comprises 17 lessons in total. The project began in July 2022, and it's estimated to run through June of 2026. Additional rounds of testing are planned. A key future objective is to make the finalized course materials, along with professional development resources, publicly available for free use following the completion of the research and usability testing. The project is also developing a new AI-based learning management system, or LMS, to support ongoing research and future implementations. Thank you, and be sure to visit our website for more information or to reach us.